All right, in this session, I want us to look at the following concepts: convergence and divergence. Okay, what do we mean when we say a series or a sequence converge, or when we say a series diverge? Okay, so in simple terms, a sequence will converge if the term numbers are getting smaller and smaller, and then it will diverge if the term numbers are getting larger and larger. Okay, so conversion is whereby the term numbers in the sequence or in that series are getting smaller and smaller. Okay, so suppose you are given this series, you are given 10 plus 5 plus 2 comma 5, okay, plus 1 comma 25 plus going to infinity. Okay, so you can see that this pattern it's a geometric pattern, because you can see that each term it's reduced by half. So it means r is equals to 5 over 10, which is 1 over 2. All right, so does this series converge or diverge? Okay, so the term values are getting smaller and smaller. Okay, so it means this series will converge, because notice that if we multiply, I want to show you something. If we multiply this term by our ratio, then it means our next term will be 0.625. Then we multiply this by our ratio, we get that this gives us 0.3125, plus when we multiply this by the ratio, we get 0.15625. Then we multiply this by the ratio, we will get 0.078125. Okay, so you can see that the numbers are getting smaller and smaller. So at some point when we multiply this, these numbers will approach 0. So when they approach 0, to calculate the maximum sum of this pattern, okay, to calculate the maximum sum of this converging series, okay, we use what we call the sum to infinity. Okay, so the sum to infinity is given by a over 1 minus r. Okay, so this formula applies if and only if the series converges. And when you say the series converges, why does the series converge? We don't say because the numbers are getting smaller and smaller. Okay, the series converges because r lies between -1 and 1. So because if you can check the value of r here, it's 0.5. So 0.5 lies between -1 and 1. So that is why the series converges. Okay, I hope that one makes sense. Right. So I want us to check an example and see how this applies. Okay, so consider this geometric sequence. We're given 27, 9, 3. Okay, so they say to you, determine the formula for Tn, the nth term of the sequence. This is simple. Okay, so this is a geometric sequence, and we know that in a geometric sequence, Tn is given by Arn minus 1. So our A value is 27, that is the first term. So what is our R value? Our R value, R is equals to T2 divided by T1. So our T2 is 9, then we divide that by 27, then we get that is 1 over 3. So our R value is 1 over 3. So it means our Tn is equals to our A value is 27 into 1 over 3 exponent n minus 1. So this is your general formula. Straightforward. Okay. So number 2, why does the sum to infinity of this sequence exist? Okay, the sum to infinity of a sequence will exist if and only if the sequence converges. And when the sequence converges, we know that R must lie between -1 and 1. So here we don't write English, we write maths. Okay, why does the sum to infinity exist? Because our R value, because R lies between -1 and 1, and your R value in this case is 1 over 3. So 1 over 3 lies between -1 and 1. So this is your explanation in a mathematical way. Okay, so now the third question says calculate or determine the sum to infinity. Okay, they want the sum to infinity. So the sum to infinity, we know that is given by A over 1 minus R. Then the first term of this sequence is what? It's 27. Okay, so this is 27 over 1 minus the value of R, it's 1 over 3. Then when you get your calculator, you punch this on your calculator, you know that it will give you a value 40.5. So this is the sum to infinity of a converging sequence, of this converging sequence. Okay, so we can check another example. Okay, you are given a geometric series 3, 1 and 1/3. Okay, they want you to calculate the sum to infinity. So sum to infinity formula, we know that A over 1 minus R, not V but R. Okay, so the first A is the first term, we already know A. Then what is R? R is given by T2 divided by T1. Okay, so our T2 is 1 and then T1 is 3. So this is our common ratio. Okay, so it means that the sum to infinity is equals to, the sum to infinity of this is equals to our A value is 3 divided by 1 minus 1 over 3. Then we get our calculator, and then we say fraction 3 and then 1 minus 1 over 3, and then we get 4 comma 5. So this is the sum to infinity of this series. I hope you are enjoying this. This is simple, guys, straightforward, and I hope it doesn't complicate you and it doesn't make you forget the knowledge that we've been engaging with. Okay, let's look at this example here. It says the following forms a convergent geometric sequence. Okay, so we are given 5x, x squared and x cubed divided by 5. So this forms a convergent geometric series. So when you see the word convergent, you must know that your R value, because we are speaking of a geometric sequence, your R value should be in between this interval. So it means when a sequence or a series converges, it means the ratio must be between -1 and 1. Okay, so the first question says determine the possible values of x. Okay, so because we are given the first 3 terms of this series, to find the value of x we must say T2 divided by T1. Okay, so this is how we are going to get the possible value of x. Okay, so by doing this we are calculating the ratio. Okay, so it means r is equals to t2 divided by t1. So in this case our t2 is x squared. Okay, and then we divide that by 5x. Okay, so remember this is our r. Okay, so now it means when we divide this, it means we're going to have x over 5, because x squared is like x multiplied by x divided by 5x, and then this x will divide this x, and then we're remaining with x divided by 5. Okay, so they want the possible values of x. Okay, so since this is a convergent geometric series or sequence, it means that our r value should lie between -1 and 1. Okay, so we're going to take our r value and substitute it on this restriction here in order to get the possible value of x. Okay, so now we're going to substitute. Where we see r, we're going to put x over 5. Okay, -1 and 1, and then we're going to solve for x. Okay, or we're going to make x the subject of the formula. So it means we're going to multiply both sides of these inequalities by 5. So it means now our solution will be -5. Okay, then here we're having x, and then here we're having 5. So it means the possible values of x, it means that x must lie between 5 and -5. Okay, so the second question says if x is equals to 2, then we should calculate the sum to infinity. Okay, so when we calculate the sum to infinity, the formula says sum to infinity is equals to a over 1 minus r. Okay, so in this case we are given this pattern, but we don't have the numerical values of these first 3 terms, but we're given that x is equals to 2. Then it means we can substitute 2 where we see x in order to form a real pattern. Okay, so when we substitute 2 here, it means we're going to have 5 into 2. Okay, and then here we're going to have 2 squared, and then here we're going to have 2 to the power 3 divided by 5. Okay, so it means the first term will be 10, and then the next one will be 2 squared, it's 4, and then this one will be 8 over 5. Okay, so these are our first 3 terms of this geometric series or this geometric sequence. Okay, so now remember we are calculating the sum to infinity. Already we can see that our a value, it's 10. Okay, then what about our r value? So when we want r, it means we're going to say r is equals to t2 divided by t1, and then our t2 is 4, then we divide that by 10, then we're going to get 0.4. So it means our r value is 0.4. So when we calculate the sum to infinity, our a value is 10, and then divided by 1 minus our r is 0.4. Then you get your calculator, then you punch that 10 divided by 1 minus 0.4, and then we get the answer to be 16.6. So this is the sum to infinity of this sequence. I hope it makes sense. So it means you are done with this question here.